Can you trust AI to process your data? Well, on today's episode of Ready Yet, we tested Anthropic's Claude AI with Wardriving data to see if it would work, and it lied to us. And we can prove it, and you can too. So before we get into this video, you are going to need some things. First off, you're going to need the Wiggle app, which is available for download on the Android store, and you can go to wiggle.net to download your data from there, or we also have some GitHub files linked in the description below. Next up, you're also going to need to make an account with Claude through Anthropic, and we'll be using Google Maps to plot our data, and to convert our KML files to CSV, you can just use an online converter. So with that being said, let's get right into the video. So to start off with doing our Wardriving data analysis, we're going to be using AI here. In this case, I'm going to be using Claude. So we're just going to upload our CSV file of our Wardriving data and type in our prompt. We're going to ask it for a list of the 10 most common open Wi-Fi network names, a list of all the WEP networks, and the 10 most common network names overall. I also want it to explain any patterns in the data. Alright, so as we can see from this data, Downtown Alliance free Wi-Fi, Battery Park City free Wi-Fi, Governor's Island, Circle Line, Honest.net, those are the 5 most common open Wi-Fi network names. 10 most common network names overall, no SSID, there's 61 of those, so those are probably like hidden Wi-Fi networks. So many open guest network names from the Downtown Alliance, Battery Park City, and Governor's Island initiatives. It's likely set up for public access. Several Circle Line ferry locations with open guest networks, probably set up for customers, sounds about right. A number of Verizon hotspots with default naming conventions. Large number of networks without SSIDs, so hidden networks. Several instances of network names with different MAC addresses indicating multiple access points, and there are very few insecure WEP networks detected. So I'm going to ask it for a breakdown based on manufacturer using the MAC address and a MAC lookup table to tally and rank the number of networks by the manufacturer. Also analyze the data and provide a summary of any patterns. Another thing we can ask it is who manufactures the vulnerable WEP networks that it detected. So here's a breakdown of the Wi-Fi networks, and it used the OUI lookup table for this. Ubiquiti is the most popular with 37 of those. Netgear and then Aruba, so those are the top 3 most popular. And so Ubiquiti are the most common. Netgear also has a large presence. Aruba and Ruckus are basically enterprise Wi-Fi vendors. A mix of other consumer devices from Apple, Samsung, so those are probably from like phones and whatnot. The 3 WEP encrypted networks are from unknown manufacturers, so it couldn't find the manufacturer of these 3 WEP encrypted networks, but it's probably from older consumer-grade devices with default configurations. So what we're going to ask it is we're going to ask it to put all of this data that it just processed into a KML file, so we can eventually load this into Google Maps and see a pinpoint location of where those devices were detected. Alright, so here it is with the outputted KML file with all of this beautiful code, and what we're going to do now is we're going to paste this into a text editor such as Nano, which I'm using here, and output this as wardrivedata.kml. And we are just going to plug that into Google Maps. So we're going to click Create a New Map here, import a new layer. Here it is, our KML file. If we open it, it will very neatly put up locations of these individual networks. So we can see here, no SSID, and this is located on a river because the person who collected this Wardrive data was on a cruise trip. So we can see all of these networks here that was scanned while on that cruise trip. Pretty neat, huh? So, our AI gave us all this beautiful information. Now I know what you might be thinking. This is a lot of open Wi-Fi networks for the short little amount of data that we have. And you would be right. Actually, if we go over here and compare it to the results we would get from running our Python file, we're gonna see it's way different. So if we scroll down here, we can click on the choose file, upload our Wardriving data, and what we're gonna be looking for in the network types is none type. So if we go down here, we see none, barely any. So we already know that the Claude AI is lying to us.
Liar!
But furthermore, if we just go over here, the Wi-Fi network manufacturer breakdown based on OUI, Ubiquiti Networks 37. If we go over here, scroll up a bit, we see Ubiquiti, only 33. And Netgear, where's Netgear? 24, and we can keep doing this for every single data point and it is all going to be wrong. The only thing it got right was the WEP map, which we can take a look here, and yeah, I mean that looks exactly like what the AI outputted for us. Now, you might be wondering, why exactly did this happen? Well, it's simple. Basically, all the AI is trying to do is it's trying to predict what word comes next, and it's basically gaslighting us into thinking that this is correct information.
Gaslighting doesn't exist, you made it up.
I mean, it sounds correct, but in reality, it's not, and it's just trying to convince us. And that just about does it for this video. There are 4 limitations you need to keep in mind, however. For one, Google Maps can only take about 17,000 data points. Claude can also only handle 10 megabyte file uploads, you're limited to 8 messages a day, and on top of that, it can hallucinate and make up fake data, which you definitely don't want. But with all that in mind, have fun Wardriving, stay safe, and thanks for watching.